Hey and welcome to day 7 of Advent of Code. Again, we are trying to solve two puzzles, and again we are using Kotlin. And we get some help from our trusty pair programmer GitHub Codepilot, which is an AI that will try to autocomplete whole blocks of code. And in the past it has helped us sometimes, and sometimes it introduced weird bugs that we had to find and fix. So let's see how it will do today. Let's start by reading. Day 7. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor, sensors indicating a massive underground cave system just beyond where they are aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whales catch you. Maybe you can help? There's one major catch. Crab submarines can only move horizontally. Okay, how did they dive then in the first place? You quickly make a list of the horizontal position of each crab. Your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of the horizontal positions match, while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. This means there's a crab with a horizontal position 16, a crab with horizontal position 1, and so on. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. Okay, they need to all move to position 2. Some are already on position 2. And this costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1. 41 fuel, position 3, 39 fuel, or position 10, 71 fuel. Determine the horizontal position that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Okay, how does the input look like? Oh wow, okay, those are more crab submarines than in the example. Let's move to IntelliJ. And let's create a package for today, day 7, and then we create a new file, day 7, and as we have done before, we create functions for part 1 and part 2, and let's execute part 1 only for now, and then we need to get the file. Here is the input. Refactoring is not available while indexing is in progress. Yeah, that's great. I just want to drop a file. Okay, let's move it to the root again. And then, oh, I moved the code file. That's not what I wanted. I wanted to move the input. Then again we will rename it to day 7. So the tricky part is I don't know yet how we should find the cheapest possible position. Let's copy this example and try some things. Let's create a comment here just for taking notes. Let's see, the result for this example was position 2, right? So what are our options? our first, well, there's one obvious option, I guess, that is brute forcing, and that's trying all positions that are available. And I assume if we sort the list, and then it's from smallest one is 0, the highest one seems to be 16, so it needs to be put between 0 and 16, because if you have like some points, crab submarines on this length, the shortest position where all aligned should be somewhere inside this. Like if all would need to move outside, that is definitely a longer distance. So the result needs to be in this range, which is already nice because it means we can just brute force. We pick 0, we move everyone to 0, which is just a simple calculation, I guess. It's just 16 minus 16 is 0. And then we figure out this number for all of them. And then we just pick the smallest. That will require us to first find the min and max in the list. So one run through the list, that is still cheap. Then for every position that we find in this range, we need to go through the list again and find the distance that every crab submarine needs to travel to this point. And the range can actually be larger than the list. Let's say we have just a list of 1 and 100. Then our range is 1 to 100, even though we have only 2 items in the list. So I'm curious what the min and max of this here is. Let's quickly calculate this to get an idea. Let's create a Kotlin scratch file. And then let's copy this in, split it by comma, and then map it to an int. Let's see, does this work? And then let's find min values, min of, what was this replaced with? It's deprecated because what was the new version of it? Min or null, okay. Guess if it's an empty list, equals values max or null. And let's see if we can run this. What is a new script context? I don't know. Okay, so it's from 0 to 1913. Oh, sorry, it's actually... Huh? I copied those numbers? What? Okay, yeah. Oh god, I was so confused. It looked like 16,000 suddenly, and it was GitHub Codepilot because now it's 16,000. And if I say shut up with the escape key, it turns back into 1913. Okay, wow. I'm not really sure if I like Codepilot doing stuff in comments. At least not without me explicitly saying, please do something. Well, okay, let's say 2000, and we have how many numbers? $1,000 numbers. So we need to roughly check 2000 times 1000 times. I think we could still brute force it. What are alternatives though? Here it's 2. We could... What kind of math things are in our toolbox? We can calculate the average. 2.0. Yeah. What actually is the average? Let's try this in the Scratch file too. Let's get rid of this, or let's keep it. Create a new. The example is this, and we split it again by comma. Map it to ints. And then the average, that is, oh, what? There's a function for that? Awesome. .9, so that is not even close to where we want to go. What about the median? Which is, if we sort the list, the number that is in the middle. Oh wow, it calculated function. Example, is there a median function? Median? No. The auto completes it, but it's anything else? No. Okay. Now is the big time for the Codepilot, because we have a list of ints and we want to write a function that determines the median as an int, and it is... Come on, Codepilot. This is the code I definitely don't want to write myself, so do it. Okay, we get the size, we sort the list. If it's divisible by 2, we pick the one to the left plus the one to the right and divide it by 2, otherwise we pick the one in the middle. I will pick this code, and I need to look up what you actually do if there is no middle element. I was expecting us to just pick the left one. Maybe that is not the case. Median. That is the English, the German Wikipedia page, which is maybe not helpful right now. Median. That's actually how it's done. Okay. Then let's try this and see if this is in any way helpful. The median is 2 here. But is this always the case that this is the best way? The least? What else can we do? What is interesting in this example, there are a lot of 2s. And if we pick position 2, it means all the 2s do not need to move at all. So that is already quite efficient. But that might not be the right solution in all cases. Let's think of some examples. Let's say there is only 1 and 100. In this case, if we pick 1, then the 100 needs to go all the way to 1. If we pick 100, it needs to go all the way to the other way. And if we pick in the middle, both need to walk that way. It almost with 2 it doesn't matter at all, I think, because the sum will always be the same distance. That is already an interesting observation, maybe? What if we add a 50 into this? If we pick 1, then 150 need to go all the way to let's write this down. If we pick 1, 150 need to go all the way, so it's roughly 150, right? I don't care about off by 1 errors right now. We pick 50, then 1 needs to go 50 and 100 needs to go 50. It's only 100. If we pick 100, it is the same, right? The 1 needs to go 100, the 50, so it's 150 again. So the best choice is 50, which is exactly in the middle. That is maybe a good thing to figure out too. Well, the middle doesn't work because the middle would be 0 and 16 would be 8. So it's not always the middle. This is 25 and this is, let's just keep this. Let's see if we can find any rule that makes sense that we could use. If you pick 1, then the 25 needs to go 25 and the 100 needs to go this. If we pick 25, then the 1 needs to go 25. The 100 needs to go 75, so it's 100. If we pick 100, then the 1 needs to go 100, the 25, it's 175, so that is awful. And let's pick 50 too, because that was the best case previously. The 1 needs to go 50, the 25 needs to go 25, 75, and then the 100 needs to go 50. So it's, what did I say, 125, I think, right? So it is still a good solution. But 1 had the same one. And here, oh no, wait, 25 was much better. And we picked the median from 3. That is not surprising. But it changes as soon as we do this. Now a ton of things need to go. Copilot. Now all the 100s need to go to 25, so it's 75, 75, 75. Here it would be cheaper to pick 100 because then it's only 175. It's likely the cheapest, especially if we do this a lot of times. So here the median would still be 100, right? The median is still an interesting choice. You know what? Let's take a look at what the median is of this values. Values, median. That is 314. Yeah, it's a nice number. What do we actually need to type in? That's it. How much fuel must they spend to align to that position? Okay. So we still need to figure out the fuel. So we need, for every position in the list, we need to figure out, even if the answer would be 314, we would still need to go through the list and figure out how much fuel that will cost. Yeah, now I'm wondering, should we just brute force it? How many entries? Yeah, why not? And if it's by any chance 314, then the median was a good idea. Let's try to brute force it. That was a lot of thinking for deciding to let's brute force it anyways. Well, oh, interesting. Wants to read this. What is read input? Yeah, I was confused. I should not trust the Copilot for things we have written a ton of times already. So we only need the first line, right? And yeah, and then we split it by comma, and then we turn all the values into ints and return this. So what is this? Those are crab submarines. Let's also rename this function read crab submarines. Okay, so we have a list. And then we could try to find the min and max. And that is the range we want to look for. Min or null, max or null, and then maybe try one function that actually, no, Copilot. We write one function that loops over this and tries to find the cheapest one, right? Yeah. Find cheapest position, and that will be, we just need the, no, we don't need the position, we need the fuel. Maybe we return a pair, because I also want to know the position, to be honest, even though we do not need to enter that here. Yeah, we just need the fuel. So what does this mean? We pass in our data, or we just make this an extension function, I guess. And then we do not even need to pass in min max. I mean, we already know if we are inside this function. Let's just return a pair here so that all the red goes away. Dot here, okay. So min can be null now. Let's handle this. Yeah, okay. Well, that is actually something where Copilot is good at, writing code that throws exceptions. Okay, now this is our range, and then we need to cheapest position. Let's make it an int, and we set it to nothing, and then our cheapest, no, fuel needed, It's also an int that is null. And now, oh wow, it does do stuff. 4x in this range, and then, okay, that is not what we want. For position in min to max, oops, we want to calculate the needed fuel, and calculate fuel to position. Or maybe we can, yeah, let's create a function right now. Calculate fuel at this position. And that is looping over all of them, and then determining the fuel, that is the current position, current minus position, and we need the absolute value. Let's take a quick peek. Absolute value, that should be the positive, because this one can be negative. Let's quickly verify this. I'm not fully sure if we have 5, or let's just print it, 5 absolute value and then minus 5 absolute. That is always giving us 5, I hope. Let's see if this is actually what we want. Yeah, we want the absolute value. That is the, oh no, we just map it to this. That is the fuel needed to move. Okay. And then we need to sum this up. And that is our result, I think. And then we see if fuel needed is null, or it's smaller than fuel needed, yes. Then we remember this position and the fuel. Wow, yeah. Copilot worked very well in this situation. Now we need to figure out which one is which. I think the first one is the position and the second one is the fuel. Or they can be null, of course, but we do not expect them to be null, since min and max always exist. So what is it complaining here? Call chain on collect chain may be simplified. Ah, yeah, there's some off. Okay. Let's run this. I really liked how Copilot wrote those print statements here. I'm a little bit confused. It seemed to be too easy. Let's see if it even runs. Oh no, we are running day 6. The old problem every day. Let's let it finish. Okay, now let's run day 7. Wow, position is 1 and fuel is okay. That was quick. That was pretty quick. And I'm confused that it's 1. That it looks so absolutely wrong that I don't trust it. And how this is definitely wrong. Like this one needs more than 194 to get to position 1. So what did go wrong? What is our min and max here? Run this again. Our range is from 1 to 5. Okay, that is oh my god, we are loading day 6. God damn it! The old problem. Both of them. Running the wrong day and reading the wrong data. Okay, let's see. That was quicker. Let's see, we had this scratch file, right? That had here. Max is 0 to 1913. That is exactly what we did. And the best position is 314, and that is the fuel. Let's try this. That's the right answer. Awesome. So brute forcing was actually quick and easy to do. And if we go back to the median was 314. Okay. So that was actually maybe, at least for all the examples we saw, the median was the actual way to do it really quickly. Let's take a look at day 2, part 2. But first, some coffee. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering? Yeah, that's definitely possible. As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of 1 step in horizontal position costs 1 more unit of fuel than the last. Oh my god. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5 now. Blah, 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 blah. This costs a total of 168 fuel. This is the new, cheapest possible outcome. The old alignment position 2 now costs 206 fuel instead. Determine the horizontal position that the crabs can align to using the least fuel possible so they can make you an escape route. How much fuel must they spend to align to that position? Okay, while part 1 was solvable with the median, the second part is not. And why is this the case? It's the case because it's not 1 step anymore. It's getting exponential. No, not exponential. Pretty linear growth, right? Each change of 1 step in horizontal position costs 1 more unit of fuel than the last. I think we can still solve this with the brute force method. We only need to figure out the new fuel. Let's rename this into calculate fuel simple. And now we can reuse this code. So let's pass in the way how we want to calculate. Oh my god, Copilot, go away. Let's pass in a function that tells find cheapest position how we want to calculate fuel. And this is calculate fuel, takes an int and returns an int. And then we use this inside here, yeah. And in part 1 we pass in calculate fuel simple. Let's change this. We need to actually perform this on a list. And then this is no longer an extension function, it is what is it actually? A list of crab submarines? Submarines? And then we perform this on this list. This needs to be a comma, okay. And then we pass in this and the position. Is right. Oh, need to change this here. And now we can do find cheapest position, and then for every position we want to calculate this. Okay, and now we shadowed our own name. Just call it submarines. Well, that is a little bit awkward to understand, since we say find cheapest position, but then we need to pass in a function that actually calculates the fuel. Well, that is fine. Oh yeah, maybe we should not have done it this way though. We just want to pass in this for one position, I guess. I don't want to refactor everything now. Yeah, let's just keep it. Okay, still the right answer. Now it's time for part 2. Let's run part 2 from main. And now the tricky thing is changing this method. We don't want this simple one anymore, we need the more complex one. Calculate fuel complex. Get a list of crab submarines, we get a position, and we still need to sum, but now we need to have a new way of calculating this. Let's just ignore this for a second. We now use this here in part 2. Pass in the submarines and the position, and then, okay, we only need to implement this. So for every step we make, it gets more expensive. So this is where we need math. First of all, we can calculate the steps like we did before. And now, go away. We need to it's the old problem of, right, if steps is 5, one step is 1, then 2 at 3, it's 4, it's 5. It's this old problem that Gauss needed to solve. Gauss sum. Sum of roots of unity. What the hell? Go away. No, that is not the thing I wanted to. But there's this story about Gauss, how he was asked to sum up all the numbers to 100, I think. And that is exactly what we need to do, except we need to do it only up to steps. Sum 100. This is exactly what we need. Yeah. Gauss, I'm not sure how it's pronounced in English, but since he was a German, as far as I know, it should be Gauss. Gauss noticed that if he has to split the numbers into two groups, 1 to 50 and 51 to 100, he could add them together vertically to get a sum of 101. Gauss realized then that this final total would be 50. Okay. So that is the thing we need to do. N times n plus 1 divided by 2. Okay. Steps. What was it? Steps times steps plus 1. And this divided by 2. And this should give us the sum, yeah. Let's try running this. Part 2. Best position is now 446, and we have some fuel here. Let's enter this. That is the right answer. Awesome. We solved the second part of the puzzle too. It is definitely helpful if you remembered this story about Gauss, because then it is easy to calculate, but you could still do it manually, I guess. If you know it's 5, you loop from 1 to 5 and sum those up. Possible too. Might take a little longer, but it still feels possible to run this in a short enough amount of time to still enter it into this advent of code. So I guess this would be possible too. Yeah, let me know how you solved the problem. If there is a quick way to do this only with math, I would be really interested in that. And yeah, you can find my solution on GitHub as always. And yeah, thank you. See you tomorrow. Bye bye.